Hello, I'm Andy King, technical editor of Good Woodworking magazine, and today we're going to do a little bit of work on basic workshop rotation within machinery. So, in the workshop, normally you've got, centrally would be your table saw, which is the heart of the workshop, if you like. Basically anything that comes through normally goes through the table saw first, and then you go to your machinery. But you're working on solid timber for that particular reason. But then you go to your machinery, such as your planer thicknesser goes next. Mouldings should be the next step really. Then you go to your spindle moulder. Then you move on to what would be your morticer for your joints, and obviously the bandsaw for any other joints if need be, cutting tenon cheeks, that sort of thing. You could obviously incorporate nowadays. You'd have what would be the radial arm saw, which is now basically a chop saw. The principle behind that is as you can see here, for dimensioning timber to set lengths, because what you don't want to be doing is working massive sort of 12-foot planks, or whatever, rather than get it down to component sizes. So what you're looking to do first and foremost is I've done here, you do a sketch of what you're looking to do in principle with the dimensions on it of your finished sizes, and from there you make yourself a cutting list, which would then give you dimensions to work to for your initial stock sizing. Then you do your ripping down on the table saw, and then you go to your planer thickness to dimension. Now the principle being is obviously what you don't want to be doing is, again, leaving yourself short little pieces. So if, for argument's sake, you're doing something that's going to need a few components, it may be a couple hundred millimeters long, you don't want to be cutting off a couple hundred millimeters, because it's dangerous to use on planer thicknesses for one thing, but also what you're trying to do is give yourself a little bit more extra room, because you should be allowing, although people will tell you snipe on a planer thicknesser is a bad thing, snipe is one of those things that you're going to get no matter what the situation. So you've got to allow for that when you do your initial machining. So it was the thing I was taught as an apprentice was basically, whenever you machine any timber, you should be allowing an extra sort of 50 milliliter end sort of thing for snipe going in and snipe coming out. That way then, when you cut that off, that gives you clean timber, and that should be the dimensions in between those two snipe areas that you're working on, so that you can actually cut your components to size. So therefore, if you are cutting little pieces 200 mil long, for argument's sake, you wouldn't want to allow an extra 50 mil either end on those, because it's just totally wasteful. If you can keep it up to a component size that's workable, and then allow the snipe on the end of those, and then cut them to length after, it's much more economical, makes a lot more sense. The other thing you've got to be contend with as well is the actual problems of putting things over machines. If you've got longer components you're allowing, say for argument's sake you need a piece at 1.5 meters long, and you think, okay, I can do that out of a 3 meter long piece, putting a 3 meter long piece over a machine isn't necessarily going to do it any favours, because then you've got to contend with all the little flaws and bits you'll get into that piece of timber. It could be like, a hollow, it could be a twist, it could be anything. By cutting it down to a component size, then by the time you put it over the machine, it's that much shorter, it works much better. Again, it's down to sort of the way you work out your timber and the way it's going to work with component sizes. And again, you don't want to be ripping your timber too quickly if it means you're going to end up leaving yourself with a big offcut that's no good for anything. You've really got to do this at your cutting list stage, that you look at what you're going to cut out of the timber, where you're going to look at what piece is going to be what, how long it's going to be in relationship to that piece of work you're doing, and therefore that will then give you, hopefully, a situation where you can cut it off to a specific length, rip it to size, machine it, and then you can then redimension again after to component sizes, and then go on to your marking out, and then onto your machining for your joints. So in an ideal world, we'd all like to have massive workshops, that sort of stuff, but if you look at this situation we've got here, this is probably about a double garage size, which even then that's a luxury for a lot of people. But what you see here is what would be seen as a classic layout for a workshop, really in a joinery situation, or a small sort of furniture workshop, that sort of thing. So what you end up with really is the heart of the workshop is the table saw, which sits centrally of the workshop itself. You need to be able to get all around it, you need to get stuff through it, you can dimension on it, so you need a lot of area all the way around it. Other machines such as the planer thicknesser, the spindle moulder, bandsaw, and the mortiser can go out to the outside walls. Now the reason being is with the planer thicknesser, obviously you don't need to be working all around it, you work across it. So as long as you've got enough room to take your work into the machine and again off the other end, then that's what you're looking to achieve. Now with the spindle moulder, what you've got here is you may have to leave it off the wall a little bit, because depending on whether you use ring fences or anything like that, because sometimes, although like a planer you invariably push through most of the time, with a ring fence you tend to do a lot of work where you're working around it, you know, doing curvers and that sort of stuff, so you will need space behind it. Obviously, all these machines are all on wheels, so you know, if you've got that situation, you can move them all into a better position if you want to. Certainly in a smaller workshop, that's going to be beneficial. The bandsaw, that can be as is, because obviously all you're doing is pushing straight through. Again, you might find to do some curve work, but the way they're set up nowadays is they work so the curves are coming out what is into the room rather than into the wall. So you shouldn't very often find yourself in that situation. But again, you can pull it away from the wall if you need to. The mortice, same situation, back against the wall, everything goes flat with the wall with it, usually goes through the machine. So again, you're getting no problems there, and it keeps everything back out of the way and gives you a lot more room within your workshop. Now the one thing which would be beneficial, I suppose, in any workshop nowadays, it replaced a radial arm saw in my mind, is the crosscut saw, the pullover mitre saw, that sort of thing. For this sort of thing, where the timber I've got here, this is what we're going to be making a project with today, and the problem is, as it comes in, it's sort of 4.2, 4.8 metres long, far too long for what we need. So you need to get it down to a workable size, because you don't want to be putting huge, great pieces of timber through a saw for no reason whatsoever. First off, it's too awkward on your own, but also you get it down to a more manageable length, and if you've got any slight twists or anything in it, then getting it down into a usable length, it minimises that twist and it goes through the machines that much easier. So with that principle in mind, what you should be looking at really first and foremost is make yourself just a simple sketch, and all that's going to be is what you're going to be setting out, what you're trying to achieve on the day, and it will give you just your basic overall dimensions, timber sizes, that sort of stuff, you know, and it will give you a workable little drawing to sort of think, okay, from there I can work out what timber I need to be using out of this to make my project. So from your initial sketch, which gives you your overall sizes, your finished sizes of what you're trying to achieve, you can then also look at your component sizes, and then you need to do yourself a cutting list. Now that gives you the opportunity then to look at your piece of timber or your pieces of timber, look at what you're going to try and get out of each piece, and also gives you the opportunity to look at it and think, right, okay, if I need to be cutting short pieces, because you've got to allow within your actual cutting, you've got to allow for snipe. Now, despite what people tell you, you know, they'll always say, oh, my planer's got snipe, what do I do to get rid of it? You're always going to get it. It's a situation where it's something to do with the way you machine. It can be a lot of things really, but at the end of the day, you should always allow for it. It's a piece you've got to cut off. It's a waste, but it's always instilled in me from an apprentice when I was machining, always allow for snipe. That gives you then the opportunity to work your component sizes. You should allow about 50mm either end on a longer piece. But also when you're doing your actual setting out or your actual dimensioning work on your piece of timber before you start cutting to length, you don't want to be leaving yourself short pieces. Ideally, short pieces are better for machining, because that way it eliminates any additional work you've got to do. So if you've got a big bow in the timber or a big twist, if you've got a long piece and you're going to be cutting it to shorter lengths, you don't want to be trying to plane all that twist or all that bow out, because what you'll end up with invariably is thick in the middle, thin at the end, or you'll end up with a piece of timber that's going to be too thin for what you want it for in the end. Now, in that situation, what you're looking to do is get it to the rough size you need it, then that will hopefully eliminate most of those flaws within that timber and give you a workable size when you've worked it down. But the other problem you've got is you don't want to leave yourself too short. So if you've got you cut components that are maybe a couple of 100mm long, for argument's sakes, out of one particular piece, the last thing you want to do is be cutting those at 200mm and then sticking them on the planer, because it's just dangerous. You don't want to be working short pieces of timber on a planer thickness, nor a table saw for that matter really. Even with push sticks, you want to try and keep a long piece. So if you have got that situation where you've got components of a set size, what you should be looking to do is work out, multiply those up. So if you need 3, then give yourself a length that will give you those 3 pieces, allow for a little bit of snipe either end through the machine, and then when you cut it off and dimension it, then you resize after that. You can do it on your crosscut saw, that sort of thing. You can cut it off on your mitre saw, anything you like really, but you do your initial dimensioning at the planer and then redimension to those smaller components after it's all been machined, which includes putting it on the spindle moulder as well if you've got to do any spindle work. You don't want to be using short pieces if you can help it. So you want to try and, it's a compromise between the two. Some pieces you need to keep that little bit longer as a set component length. So if you had a piece that's this long, obviously, then you need to allow 50mm either end. but you may find it works better if you've got 2 pieces. You can allow that again, because that's quite a manageable length. And you look at your timber first and foremost, and you check it for things like twist, and you check it for bow. And if it means you've got to cut it, then you've got to cut it. But invariably, it's nice to keep it a little bit longer, but not so long that it's unmanageable and it's going to leave you with more problems than you started off with. So from that point of view, you then look at your actual timber itself, and you work out from your actual little drawing, you do yourself a cutting list, and that just gives you the basic pieces. So it will be, in this situation, we're going to make a little frame with a door inside it. So you need basically 8 components, which is going to be a head and a sill for the frame, 2 jambs, 2 stiles for the door, and you'll have bottom and top rails for the door as well. And we're going to put a panel in the middle as well, which is going to be just a piece of MDF just for speed. You could actually, glue one up if you want to do it in pine or whatever, but for a piece of pine work like this, invariably it'll probably be painted, so it doesn't really matter. So from that point of view, you then work out, I've worked it out, I'm going to make a frame that's going to be 75 by 50, and it's going to be, I've worked it out, it's going to be 700 high and 500 wide. So all these pieces are going to be 75 by 50 sawn and then planed to about 70 by 45, but something about 5 mil off for machining. There's going to be a rebate in it, so I've got to allow for that again within my machining, and that will be done on the spindle moulder. And then within the door itself, the door's going to be very, very simple. It's just going to be a straightforward flat stock door. So it's going to be, I've worked out again, 75. It's going to be about 30 mil thick. So it'll come in at about sort of 25 by about 70 finished. That's going to have a plough groove in to take the door panel. But within that as well, there's going to be mortise and tenon work. So again, within this feature, what we're going to be looking at is not only cutting to size, it will also be, we're going to start using, from the cutting list and from the stock dimension sizes we've worked to, we're then going to be looking at how to use setting out properly using a rod, okay? And from that point onwards, as soon as you've got your rod, that's it. No more measuring involved. It's just taking straight off the rod, straight to machine, simple as you like. And that is always a reference. If you get a little bit confused, you go back to your rod and you can look at things, and it gives you everything you need to know off of that thing. It shows you your joint positions, it shows your rebates, it shows everything you need to know just to work straight from that position, and away you go. It's the most fundamental thing you'd ever want to know, and it should be used pretty well every stage of anything you ever make, really. To me, the most important things in any work is certainly facing edge marks and working to a rod whenever possible if you're doing something like this, where you're going to end up with something's got to be a certain set size, and something's got to be a set size to fit within that. So a door and a frame are a prime example of that. So that's what we're going to try and achieve today anyway.